Let's now sketch some graphs involving the modulus function, and this will also revise transforming graphs as well. So up first, we're going to do the modulus of 2x take away 5. Y equals the modulus of 2x take 5. Now the way I'm going to do this is I'm going to sketch the original modulus of x graph and then transform it. So think about what effect the 2 will have and also what effect the 5 will have as well. I'm going to use GeoGebra to demonstrate the transforming of the graphs here. I've already drawn the graph of mod x, and there it is on the screen. Now let's think about what effect the 2 will have. So on the screen I've entered f of x is the modulus of x. So if I want to do the modulus of 2x, then I'd do f of 2x. And you can see on the screen the modulus of 2x is this grey graph, which is steeper than the blue graph. So it has been compressed towards the y-axis by a factor of 2. Another way of describing that is to say it has been stretched in the x-axis, but with a scale factor of a half. So a stretch of a scale factor of a half looks the same as a squash scale factor 2, but this is happening in the x direction. So the points are moving towards the y-axis in this case. Now what effect will the minus 5 have? Well, you might think that the minus 5 will now move the whole graph to the right by 5, but actually it won't. And that's because we've been squashing the graph in the x direction. So we've already had a squash of a scale factor of 2. So now when we introduce the minus 5, it won't actually move it to the right by 5, it'll move it to the right by a half of 5. And I'll demonstrate that by typing f of 2x take 5. Because I called the f function mod x, then f of 2x take 5 is the modulus of 2x take 5. But note, it has moved to the right by 2.5, not 5. So you've got to be careful with that. If you've got a translation combined with a stretch or a squash, you've got to think about the combined effects of those. Another way to describe that, if we go back to the graph, I'm going to rewrite this as the modulus of 2 open brackets x take away 5 over 2, or 2.5 if you prefer decimal. As you can see, that is still equal to y. So if we expanded the bracket x take 2.5, you'd get what we had earlier. So those are the same. So this is another way of looking at it. If we did the translation first, then we'd move to the right, as you can see in the brackets, by 2.5, and then the squash in the x direction with a scale factor of 2. But if you do it this way round, the squash would then not be towards the y-axis, the squash would be towards the line x equals 2.5. Let's bring GeoGebra back to demonstrate that. So if I do the translation first, so if I do x take 2.5, so the modulus of x take 2.5, as you can see, that has moved to the right by 2.5. If I now introduce the 2, this is now going to squash it not towards the y-axis, but towards the line x equals 2.5. So keep your eye on the green graph, which is the graph of the modulus of x take 2.5, and then I've got this vertical line x equals 2.5. If I now introduce the 2, notice how, yes, it's being squashed in the x direction, but around this vertical dotted line and not the y-axis. So these examples depend on what order you're going to do them in. Are you going to do the translation first, or are you going to do the stretch first? Just be careful. So let's put the answer on. I've drawn the graph. We need to see 2 lines and then show where it touches the x-axis now. That happens when x is 2.5 and y is 0. Let's also show where it goes to the y-axis as well. So at this point on the y-axis, just like any point on the y-axis, x is 0. So if we put x is 0 into the equation here, we get y equals the modulus of 0 take 5, which is 5. So this goes to the y-axis at 5. Okay, moving on to part B. Now in part B, we're going to do 2 times the modulus of x and then take away 5. So again, we have a 2 and we have a minus 5, but they are in different positions. Previously, both the 2 and the minus 5 were both inside the modulus. This time they're both outside, so we're going to get quite a different graph here. Once again, let's begin with the original modulus graph, and that's on the screen here. Let's introduce the 2. So if I do 2 lots of f of x, we're going to get twice the modulus of x, which is just steeper. So that's a stretch in the y direction with a scale factor of 2. And then if we take away 5, so I'm going to do 2 times f of x, but then take away 5, that moves the whole graph down by 5. So we've had a vertical stretch in the y direction, scale factor 2, and then we've had a vertical translation in the y direction, down by 5 units. There we go, I've drawn the shape on the graph. We know from the transformations that the vertex, which used to be on the origin, has now gone down by 5. So x is still 0 there, but y is minus 5. Let's also work out where it's crossed the x-axis. So when y is 0, we get 2 times the modulus of x take away 5 is 0, which means 2 times the modulus of x must be 5. So the modulus of x must be 5 over 2, or 2.5, and there's 2 values that x can take which satisfy that equation. So if the modulus of something is 5 over 2, then the something could be 5 over 2, or it could be negative 5 over 2. Those are the 2 numbers that when you put them into the modulus function, they give you an answer of 5 over 2. So here x is 5 over 2, 0, and here x is minus 5 over 2, 0. Don't know why I've put 2 minuses. Let's get rid of 1. Okay. Also, I don't know why I've been switching between decimals and fractions, but there you go, they're the same thing. So that's example 8.1.3.